Okay, so today we are going to see. Are you seeing the screen? My screen?
Yes, ma'am.
Okay. Okay. So now today we are going to see two things. One is the training as well as the testing. Okay, and how we are going to train the neural network and how we can test the neural network. It's a simple example, but it's a general example only. It is not very specific. Probably from my last class, I think. Where's it comes? No. Yeah. So here we have taken some issues like basic elements, right? The weight factor, the threshold, and how normally activation function for a neuron, and all these things are main key factors for the function of a neural network. So let us see that one. So let us see training. The best training procedure is to compile a wide range of examples. See, wide range of examples means suppose you take a data collection of all the people being in the campus, okay? And from that, your objective is like, okay, you take some analysis of the people, okay, the students having high IQ between 80 percentage to 100 percentage, which is not possible. Okay, 80 percentage to 100 percent we keep it. But what you are doing is you are going to take a data of the entire people from the lower level of age level to higher level of age level, whatever we have it in the university, irrespective of whether they are educated, uneducated. Okay, so you are going to have a full collection of data, but that includes the students community also, where we have also a database for their grading or their marks or whatever. Okay, with that we are calculating. So in this data is quite wide range of data, because the data has input from the people who have not enrolled for the course. Okay, as well as even in the enrolled people, the people will also not belong to the high IQ. Okay, so you have a different clustering or classification of the data. So whatever data you are taking should have kind of what is that extra features, so that the neural network automatically recognizes its purpose and it executes only for those data that has to be extracted. So normally what is this is like we have to provide a wide range of examples. That means the problems for more complex problems, more examples are required. Okay. Even if suppose like okay, suppose this is one example of data collection I said, but you can also have a different kind of data collection. Okay. So the trial and error, so many times you have to execute the neural network for some different databases, and you have to make the neural network as a robust one by adjusting the weight factor, by triggering, identifying the proper threshold value and everything. Okay. So to create a robust and a reliable network, in some cases, some noise or other randomness is added. Means when we add some unwanted data to the data, what we are going to use it. Okay. Suppose we have a data to be processed is a kind of function of X, but we don't want we have some noise or some errors or some nonsense data that we say is a different a function of Y. But what we are going to do, we have to give the input f of x as well as f of y, both together. So that we ourselves introduce some randomness in the input. Okay. So the randomness is added to the training data to get the neural network familiarized with the noise as well as the natural variability in the real data. So what is the purpose of adding this? Definitely there is a natural variability. Whatever data we collected, it will have its own variability. This is by nature. You cannot avoid it. So what happens is the neural network will be efficient enough to identify the natural variability as well as the unwanted signals. So, when poor training data inevitably leads to an unreliable and unpredictable network, this is the problem. That's what we have to train the data neural network very properly. Usually, the network is trained for a prefixed number of epochs or when the output error decreases below a particular error threshold. Like whenever we say there's a threshold, for everything there's a threshold. To increase or the adjust weight is also there is a threshold. To keep them, what is that? The neuron activation function is also there is a threshold. To identify the error difference, there should also be a threshold. If the error difference is increasing, adjustment. So for every adjustment, you have a threshold. So we have to be very careful about the error threshold. Then special care is to be taken not to overtrain the network. That means, your parameter adjustment should be in such a way that the network only recognizes the desirable data, not all the data. You don't overtrain the network. Okay, so by overtraining, what will happen? The network may become too adapted in learning the samples from the training set and thus may be unable to accurately classify the samples outside the training set. See, we have normally an example. I'm coming to a problem here. Let us see. We have a data. This is a scattered data samples just plotted against x and y. You don't know what is x, you don't know what is y. Probably what is x, some patterns, okay? And you have, you can see two types of data. One is given in circle, the other one is given in, what is the name of the symbol? People who play cards may know this. What is the name of the symbol? Anybody? Something like a clover?
Ma'am, clover. Clover.
Okay. Okay. So the thing is that now the objective is we have to classify the what is that? The circles separately, and we have to understand the relation, and we have to understand there is some kind of difference data. Okay. Let me read this. I will come back to you. So this figure 3 illustrates the classification of results of an overtrained network. The task is to correctly classify the two patterns X and Y. The patterns are shown in this, and the test patterns were not shown during the training phase. First, this is the first trainings. Okay, what we are going to do is, okay, now the issue is we have to classify the data so that most of the red circles are coming in one side and few red circles are, we can consider this as an outlier. Possibility is there. Okay, so if I copy paste this, oh, okay, are you able to see this?
Yes, ma'am.
Okay, so I can also classify the data like this by putting one line. Okay. I can also classify like this. Okay. But the problem here is if I put line like this and if I put line like this, okay, what is the problem? Because see now the number of spheres, that is, let us consider this one slanting one. 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5. So I have equally divided. There's no classification. If I put the line like this, I have 1, 2, 3, 4. Okay. And I can do this. Okay. But the problem here is now if I take a difference between this distance, okay, this distance and this distance, you have a possibility of even getting more classification like this. This is a poor calculation, I mean a generalization. What happens is like every time when you do like this, it is this is a demarcation line that separates the classification, and with the close to its vicinity you have a data. So what you are trying to say is if you make a delta, a standard deviation, this is almost falling in this category. So either plus or minus you put, that goes this side. So the number of data what you have to classify is you have to ensure that you are having a proper separation, because you have a gap from this data to the central line, you have a gap, you have a proper gap, and you have a gap. So what happens is these four spheres, you can consider this as what are their outliers, so that you have mostly 6 datas are clustered. Okay, but the thing is that there is also some probability you can also make similar line, not like this line. This is also a best outlier because you have a proper demarcation with this, and this is not considered, and this is coming this. So this is a simple line, like I'm talking about the cartoon. This cannot be the real situation. Just to tell you the concept, a classification requires an additional function, which what the additional function is a line here. Okay, so I'm using a linear function to separate the classification. Okay, so what is this? This also has a training set. This also has a test samples. Okay, these are all, what is this? The red one, I mean the sphere ones are the training samples. And you have this as a test samples. So what happens is the test samples also given, that is also scattered with this. So the test samples are already tested. So the data, whatever you are getting within this vicinity of the test samples is also accepted. Okay, so this is more common. Your distribution is more common. Probably all your test samples are this side, and all your training samples are that side. That is not a good cluster, because your training is not understanding the test samples. Okay, so the problem here is you have to find a function. Here it is a linear function, so it is easy to classify the data. Understand? So now what they are talking about in the figure left side, each class of the test data has been classified correctly, even though they were not seeing during the training time. So training time we are using only the training data, and later we will add the test samples together. After that, when a neural network is functioning and it will classify properly the what is that? Then it will give you a good generalization of the data.
Excuse me,
So
ma'am.
yes,
Ma'am, I have a doubt in the graph. Ma'am,
okay.
can you identify noise data here?
No, actually, you can also add a data. The test data normally considered to be a standard data or a noise data. If it is a standard acceptable data, this distribution is good. But if it is a error, then that has to come this side and your data has to go that side. That's upon the test samples what you are using. Understood?
Okay. Okay. Okay.
Now this test sample is favoring the training samples to ensure that the new data, whatever is being recognized by the neural network, is also an accepted data. That's what we are using the test sample. Here the scattered pattern we can accept it because both the data are in the same classification. This is already known data, so we know it, so we can allow this. But as you asked, if this is the error, okay, what should be? All this flower should be the below the line, and the red dotted sphere should be above the line. Then it's a proper classification. Okay.
Okay, ma'am. Ma'am, and second thing, uh, during the training time, we are using numerical value, right?
Hmm.
So,
Yeah,
is it possible that we can use a string character as a training set data?
definitely.
Okay, okay,
Even if you put as a string and every data from your string should be related to all the cascading parameters because where is that? Okay. Because every weight you can put as a string. Okay, but even then you should the threshold is going to vary. Okay, I mean threshold also you can keep varying, but it is not necessary that for every weight it should vary. For one samples you can keep one set of samples you can keep one threshold. For another set of samples you can give a difference, but this will be varying for every adjustment, as well as your activation function. This activation function is also influenced by your threshold value because the level of threshold value you put in will be subtracted. So your activation function is highly dependent upon the quantum of the threshold. So even if you are using a string values, whatever parameter is needed for every operation should change. But threshold doesn't require a change for every step. You understand what I'm trying to convey? So that you should ensure.
okay, ma'am. Yes, ma'am. I understand. Okay.
Okay. Okay. Okay. So now I'm coming to this. So the trained network is said to have a good generalization performance. And in the right side illustration, some miscalculation of the test data. The network initially learns to detect the global features of the input. Then as a consequence, it generalizes a very, what is that, very generalizes very well. But after prolonged training, the network starts to recognize individual input and output pairs rather than settling for weights that generally describe the mapping. So this operation is done, make sure that the neural network is going to recognize a new database or new inputs also in the future. So once the model has become robust, there is no need for any change in the weight adjustment. That's what I keep on telling. So you can keep this model for as a standard model for other data as well. Just 1 minute. Huh? Okay. So now when we are training, this is a training. Okay. So but what are the parameters we have to check? Choosing the right initial weights. So the learning assignment, I mean algorithm uses a steepest descent technique. Here again a new technique which I have to explain separately. Okay. Okay, so you remember in the last class I was explaining something, right? Okay, I come here, I read the sentence again. String algorithm uses a steepest descent technique which rolls straight downhill in a weight space until the first value is reached. Oh my God, what I'm doing? Where is my whiteboard? Okay, okay. So let us make one graph. This is the trials. Oh my God. Please excuse me on my handwriting. Okay. So what okay, this is all demarcation. How many of you have younger brothers at your home? Nobody, yeah? Okay.
Yes, ma'am.
Do you have any experience about them that they are writing in your note?
Yes, ma'am.
Okay. So let us see. Okay. We are going to adjust some weight. Okay. Okay. This is I'm talking about how we are going to adjust. Okay. In one particular time, this is. So there is a variation. In mean, I want to just to tell you there's a variation. What is this? There's an increase. There's a what is that? No change. Then it is increasing, coming down. Okay. So this is a topic that you will be studying in third semester. That also I'll handle, but I can explain it now. If you consider this, okay, is a top one. There is you can make the same one in a three-dimensional way. There is yeah correspond to this. You have one short correspond to this. You have one more convergent. Correspond to this. You have one more blocker. Correspond to this. You have one blocker. All these things. Okay. So now what I'm going to draw is you will be having a concentric circle. Then you will be having a big concentric circle. You understand what I'm trying to play? Okay. So I'm going to redo only this. Okay. I am going to only redo this, and I can make this a concentric circle. This is a concentric circle. I mean, I can draw here. This is one. This is one. This is one, and this is one. So what is this? This is the least disturbed state, which is the preferred state for us. Okay, this is the okay state for us because every variation there's an increase, but this region, if you see, there's a decrease. Your weight is stabilized. Then the weight is disturbed. Okay, so what is the preferred is you have to choose the weight for this configuration or this trial. Then you have to use the weight value in the neural network. How you have to identify this? Because you have only taken the, if you do a graph in a 2D, it is very easy to take a point, but it is not a 3D. The problem is not a 3D. The problem involves the changes in the threshold value. The problem involves in changes in the activation value. The problem involves by changing the weight of every node. So this is a complex problem. So you have to use a technique. Probably when you are coming here or something, you have to find a technique or a mathematical approach that brings down, that walks down the valley and identify the least disturbed state. Understand? Hello.
Yes, ma'am. Ma'am, here in the list stable state, we need more activation, no?
No need,
More
na.
active.
No need, no need. See, you need more activation to come here. You need to cross. You have to climb up only. You need energy. To fall down, you don't need any energy. You can relax. You understand? While stepping down, you don't need energy. You can come with the gravitational pull itself, but we are not using the gravitation. But there's a ease, to relax the energy. But when you are climbing in the hill or climbing in the staircase, only you need energy. But after this, if this goes up, you need activation energy. After that, you need activation energy. Okay. I mean, increase in the activation energy. I'm not saying that no activation energy. This is a stable, this weight belongs to a weight profile, which is very, what is that, non-distorted state. This gives a proper output for the neural network. That's what.
Okay, ma'am. Okay.
Okay. So,
Yes.
everything you have a concentric circle and the least minimum stage we have to identify. The way we walk down is every concentric circle, we have to step down, we have to step down, we have to step down, we have to step down. Okay, this process is like how you are going to take a slope. Okay, every point you take a gradient of the vector. Okay, then the gradient of the vector goes down means you have to follow this. So if it is a negative gradient, it always says that the function is decreasing. So you have to go down. If the gradient is increasing, you should not take it. So one such method is called, which directly comes, is the steepest descent method. Okay, there are another methods also. I love to do it, but that we'll learn it in the third semester. Okay, so let us stick only to this. That is the steepest descent technique, which rolls straight downhill in the weight space until the first value is reached. You understand now this sentence?
Yes, ma'am.
Okay. So this makes, who is this person answering to me every time? I just want to know.
Ma'am, me, Bablu.
Okay, ma'am. Okay, what is your background?
Ma'am, I'm from biotech.
Okay, good. Okay. What happened to others? All are there?
Yes,
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 ma'am.
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 Yes, ma'am.
Yes, ma'am.
You guys are following what I'm saying? I'm sorry because I'm trying to use the whiteboard. It is also not that clear, but I try my level best. You follow. Maybe you can see this as a scribbled one, but I hope you can understand what I try to convey. Right?
Yes, ma'am.
Okay. Okay. So now I'm coming to this. Okay. So choosing the initial weight value, I mean, under this heading, we are talking about the variation, then we have to identify the value. This makes the choice of initial starting in the multi-dimensional weight space. That's what I was talking. We are not having a 2D, we are not even having a 3D. It is a multi-dimensional space, weight space. Okay. So which is critical, then we have to identify this. However, there are no recommended rules for the selection except trying several different starting weights. You can also, if you are little more, lazy, you can also start with your random weight values and work on it. So then you have to keep it in mind saying that if the error difference is increasing, then you cannot use that weight. Okay, I mean weight adjustment. So each time you have to make a condition saying that if the error difference decreases, whatever adjustment you do is the right one. If not, then you have to work on it. Okay. So this is one choice. So one parameter, then a very crucial parameter is the setting up the weight in the neural network. Then the another one is the learning rate. See, we have an equation. You have to know that the eta and alpha are the learning rate. This is eta is the learning rate and you have a momentum space, right? So that how the momentum is coming? 1 minute. Huh? Okay, so now What is the momentum that talks about? I explained in the last class. It is the effect of the past weight changes on the current direction of the movement in the weight space. See, the keeping that every trial we are going to work. See, we have one weight. We are jumping into the new weight. We are jumping into the new weight. Okay. This steepest descent, what it does is immediately, suppose for a cycle n, it is here. For the cycle n plus 1, it is taking a new weight. N plus 2, it is taking a new weight. Okay. But this n plus 1 weight is not what is that? It is not used when it is here. But we have another approach which I really skipped to tell you, that is the conjugate gradient. Why I am doing this? That's a conjugate gradient method. Okay. What does it do? What does it do? There is the weight here, and the direction is considered, and suppose if this is, I want to jump here, but the weight here and the direction is considered to do this. This is steepest. But what conjugate does? This also takes the previous weight factor and the direction and takes the average and move it. Okay. So that see here the important problem is we are making a concentric circle, right? That means we are cutting this weight valley in a different rings, but the width of the ring matters. Suppose when you are stepping down in a step which is more than 1 feet height, how you have to step down? You have to jump down. You may skip or you may fall, right? So the step size should be comfortable enough for you to put your leg down, correct? So that the width of the ring should be important. If the width of the ring is not taken care properly, what you can do, you can take this point and this point, take average, and you can make your own slope and come very fast. That's what the conjugate gradient takes. Conjugate gradient, what it does is, it is taking the present weight and the direction as well as the weight and the direction in the previous step, and it is taking the average and it is going in a faster speed. So the people, when they are using the search methods, what they do, at the beginning they take the steepest descent, then in the middle of the program they change the approach to conjugate gradient. So that whatever happens, that comes to the valley, that ensures the least confirmation. Okay. So this is another one. This probably this extra I have learned it. That's what this momentum terms. What it is determined from the effect of the past weight changes on the current direction of the movement. So this is highly directional, as well as this is taking the memory from the previous run as well. So you have to be careful in using the good choice of both learning rate and the momentum. Okay. So momentum is taken from the n minus 1 cycle. Okay. So, but we are calculating the weight for the n cycle. Okay. So this is the sentence that talks about where I was. Okay, learning rate effectively control the size of the step. What is the size of the step? The size of the distance between the concentric circles. It is the following.
Yes, ma'am.
Yes.
Okay, so learning rate effectively control the size of the step that is taken in multi-dimensional weight space when each weight is modified. So very important, every step we are modifying every weight connection. So if the selected learning rate is too large, then the local minimum may be overstepped constantly. Understand? Problem is you all end up the minimum, but is it this minimum or is this minimum? So you should find out which minimum it is. Probably it is very preferred that you have to identify the global minimum. That is the least minimum. These are all the local minimum. This is one local minimum. This is another local. This is another local. But this one is the global minimum. So you have to ensure that you are using a very, very global minimum. You should not take a local minimum. Okay. So if the learning is too low, the number of iterations required may be too large. Means what? Learning rate is too low. Means every step is very slow. Then you have to make more number of trials to make to identify the proper weight space, so that the learning rate itself, you cannot keep it too large as well as you cannot keep it too slow. So you have to adjust the learning rate also to have a proper performance. Okay, so higher order learning algorithms, actually these are all not important, because this is a very introductory one. This is not talking any methodology. So I will finish with this, but you can also use for this fifth one. You can also use this the function. How you can also use this full content. I think here also there is, yeah, they're talking about gradient descent learning. Okay, so there is some delta they are taking. See, this is they are talking about the error. E is the error, and in the weight space they are taking, and the proportionality, every time it is proportional, and the proportionality they are identifying by approximating with some polynomial, and that eta value they will take it and they will use it. Okay, so you can use this article also. I think exclusively. What about? um, like, okay, so these are the key parameters. Then you can see to it while training and testing the network. Okay. So with this, I finish. What is this? ANN. Please make a proper note. Okay. And what is your syllabus? See how you guys are finding your semester 2 papers. No sound, huh? Students.
Yes, ma'am.
Okay. So what about your papers, other papers, semester 2? You find it easy? Why no sound? Hello. Okay, let us see all your faces now. Connect your video. Hello. Yes. Let me see all your faces. Why you are skipping, and then it is not a pulse. I want everybody to see for a while. You can keep your video on. Navarasi, Megha, Divya, then Madangi, and Subhash. Why it is off now? Keep your video on. Nishi, where is Nishi?
Yes, ma'am. Turn.
Video will not come, ma. Chandan, Bablu,
Turn, ma'am, but
Ma, Amal, and Vishal. Udayavanan,
Yes, ma'am.
Sadia, Chandni. Very okay. So how do you feel about your second semester papers? Huh?
I mean, fine, ma'am.
It is fine.
Yes, ma'am.
Okay. So how about this algorithm paper? What I teach? Huh?
Ma'am, it
Amalraj,
feels little bit tough,
it is little bit tough, huh?
ma'am. But I think we can learn it soon.
Why it is tough? Because you are a biology background guy, you know neuron. You're simply, making one more animation in the neuron. You think about yourself as a film director. Then artificial intelligence paper will be easy. Because we are going to mimic everything what is there in the biology. Correct?
Yes, ma'am.
I have not made any mathematical equation for this because if you take the real artificial intelligence book, you cannot read, even I cannot read and understand because they will be using all operators and they'll be using all differential and all partial equations and everything. But I'm trying to give you a very, very essence simplified content where you only understand the concept. And why it is tough? How many of you say this is tough? You have, I think you have attended 4 classes or something, no? How many classes? I took 4 or 5,
Ma'am, I think this is sixth class.
sixth class. Okay, so you really feel this class tough?
No, ma'am, it's like a new concept for us, no, ma'am. So it
Yes.
takes time for us to understand and everything. It like in classes we get to understand things, but I have to like do more practice on it. I'm saying
Yes.
like that.
Okay, okay, okay. See,
Ma'am,
yeah, tell me.
sometimes we feel we need to clear more terminology.
No problem, no problem. I'm not saying that why you are asking. No, you should ask doubt. See, for me, I am very frank. I'm not doing research in this. My specialization is molecular dynamic simulation, drug design, and the other programming writing. Okay, this is like a most the person who made a layout of this computational biology course is mine only, and it was done in 2010. And I was insisting that this paper should be there for the student because this is like in after a few years you see molecular dynamics will be there, but the entire world is going toward the artificial intelligence. So even we are, I mean, if you ask me training lab or something, I cannot do it because for me there is no research experience on this. But it is really fortunate that you guys are exposed to this subject. And if you have your own interest and you can do it as a, on your personal interest, you can do it and you can excel it. Because by the time you get your degree and go out of this space, there will be lot of opportunities for this artificial intelligence. Okay. See, every unit, what I am giving you here is a different subject. It needs more books to read and do it. But we are trying to understand only the introductory part. Okay. Don't keep a kind of mindset that this is tough. I'm trying to give you in a very, very simplest way. Okay. Are you able to follow my classes? That is very important. Are you able to follow?
Yes, ma'am.
Yes, ma'am.
Okay. Then.
Yes.
Okay. Okay. Okay, so with this, we will finish this unit today and we will start, I think, next class what I will start. Yes. Probably I like to do this support vector machine. Always, my algorithm paper, I go from the bottom. So fifth unit I finish, fourth unit I finish, then I jump to unit 2, then I go to unit 1, and finally I come to unit 3. Okay, so from the next class onwards, I will take this support vector and immediately I will finish this Bayesian network. After I finish these two, we will make first internal. Okay, So anytime after I finish the base in network, I may give you 2 or 3 days only, or maximum 1 week time for your next internal. So you should not say that, madam, we have not prepared this online. Even though this is an online class, this every internals and everything should go by the schedule. Okay, please prepare
Okay,
your
ma'am.
content. Please prepare your content. You know, it is 2 marks question, 5 marks, 4 marks question, and 10 marks. You know the university pattern, right? I never change the pattern. I will not tell you that you do multiple choice. For me, that is a stupid thing. Any student should understand the logic and write with their own imagination. They should be descriptive. Okay, I will never change my exam pattern, and in the future also you should not come to me to change the pattern or something, because I am very strict on this. Okay, okay, keep preparing the notes, and as soon as you finish this notes for the entire unit, you send me a PDF file. You take a photograph and convert it as a single file. Then I will to name the file and send me. Don't send it randomly. There should be some common name. Okay, then only it is easy for me to take it from my email and put it in a folder. Okay, you keep ready. When I say, you send it to me. Okay.
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
Oh, okay, ma. So be safe. Take care of yourself, and you know. Okay, probably the next class is on Monday.